All right. So,
Cool.
what we're going to be doing. So, this is the assignment, alternative assignment for the PG&E stuff. If you can't access it directly, when you get to, um, if you can't access it directly from the link, when you go to the web page, the ebook, you log in, you go to assignments. It should be at the top of the list, which is just PG&E alternative assignment. How can you design a wind power generator? Um, and so that'll be what you work on, and then from there you click on it, it'll bring you, it might say open, it might bring you to it, I forget exactly how it is for the student version. And then what you'll do is you'll have here, if you click on this eye, it tells you the design criteria for the um, wind turbine that you need to create. Overview gives you an idea of how to do things, so like just what you're really trying to do.
Oh
And
yeah, I tried that. I didn't do it.
in this case, what you need to do is you need to basically turn wind into electricity. And if you click these informations, it tells you what each of these things are. So, like, you have your blades, you have a gearbox, you have a high-speed shaft rotation into electricity, um, and then low-speed shaft, high-speed shaft, rotor, battery, solar cells, and all that. And you need to figure out how to turn this wind into electricity. To give you a hint, you're probably going to need a wind blade, and then for the ending, you can probably either use high speed or low speed. Either
Does
one
it
should
matter
work.
which shaft you use?
Does it matter which shaft you use? Yes, it does matter which shaft you use. But basically, you could go through. If you think about it, you have your blades, which have to be attached to what? What do you guys think the blades have to be attached
Well,
to?
the thing that looks like the pipe connector.
The rotor.
Not yeah, the rotor. Yeah.
Yeah. So the rotor, and then from there, if we think about it, how fast are the wind blades spinning? Are they spinning really fast or not that fast?
Pretty slow.
Not that fast.
Not that fast. So if we
So
think
so Dan,
about
I
it,
did all of this, but how do I save it as a PDF? That's all I need to know.
oh no.
You go to
you do
File.
that, and bam, and then you check design, and then you go
Wait.
here, and you're going to be doing a bunch of tests. And so you'll do some things, so you can like experiment with that. You're going to test your wind turbine. You can skip ahead to the end, or you can full screen it, because I'm a dum dum. And what it'll do is it'll sort of give you some information, except this time, it's like, oh no, too much vibration.
Too much vibration.
So we can do that. We can be like, lubricate gears and excessive heat. We can reduce maximum speed at which the thing turns off. And we can save this to notes as sort of some stuff we can add in. And just remember, for criteria, has to be above 300 kilowatts and has to cost less than $1 million. I think it also says that down here. And then after you get enough data that you want to use, you can have a table, or you can add additional notes. You can add your table to report, and then at the end of it all, which you'd probably want to add your table to evidence, and you can actually click and sort of have it turn off or not display things. So if you have some data that's like not really useful to you, you can turn off those rows or perhaps the columns. But the idea here is that you're doing a sort of choosing the best design, keeping in mind of your vibration, heat output, as well as your power production, making sure it meets the minimum needs. When you have the table set up how you want, you click done, it'll put it in like that. And then if you want to save it, what you can do is click this print button after you've filled it all out. Click the print again, it'll load up to the Google Chrome's print, and then basically you can do save as PDF, and it'll save it as a PDF, and you'll be able to then upload it to Jupyter as a PDF in the correct assignment. But make sure to put in your name, all that, the dates there, and then you're going to be sort of making a claim and sort of using your data that you got to give a reasoning as to why. Additionally, if you want to know, there is a rubric of how I'm basically going to be grading you under support, so you can double check that information to go through and make sure it's accurate of how we want it. You can also read the background if you're really just a little bit more curious about how wind turbines work. And then there's a guide of some of the things, and then some questions to really think about when you're answering the reasoning or various parts of this lab, like what are the main steps to convert wind energy to electricity using a wind turbine? How does the blade length affect the power output of the wind turbine, and what factors affect the cost of the wind turbine? And these are just good ideas to sort of keep track of. Are there any questions?
I don't understand how you included the table in that. How do I?
Okay,
Never mind.
so
I
in
figured it out.
here, after you do that, you do your tests.
Yeah.
You run through. You can skip to the end of the little video of the thing working, which you can just be like, boop, and then it's
Never
like,
mind,
oh no, there are these issues with the heat.
Yeah.
Wait, how much? How many watts? Over 300?
Yeah, it needs over 300 kilowatts and be under $1 million.
That sounds complicated.
Maybe a little bit. But that's sort of what's going on, and you can save it to notes, add the table, adjust rows as needed, and you can even reset. You can go back to the initial state. Actually, probably don't click that.
I did it.
Boop, boop.
Oh, I think I did it again. 304 kilowatts. $911,000.
So, that's sort of what's going on with a high variable, and then if you do the variable, boop, 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 boop.
Dan, did you record that?
Yeah, I did just record that.